So again I am considering the same problem and we will complete this today. So the first problem for today is translate Tx is equal to 10, Ty is equal to 20, rotate 45 degree, scale is equal to 2 and this is equal to Sx and Sy. The vertices of the triangle are 10, 20, 60, 20, 80, 120. So apply the above transformation using the matrix method. So we will apply here the matrix method, and first we will apply translation, transformation, and then rotation, and then scaling. So we will complete today the problem first. Another problem for you is the translate Tx is equal to 10, Ty is equal to 10 and Tz is equal to minus 20, and this is 3D based, and scaling unit is 2 units, rotate about the x-axis. So here it is already mentioned, because in case of the 3D we can rotate about the x-axis or y-axis or z-axis. So in the problem it will be mentioned always about the rotation about x-axis or y-axis or z-axis. So here in the problem it is given already, rotate about plus x-axis, and this is equal to 90 degree. It means theta is equal to 90 degree. Okay, so first you have to apply Tx is equal to 10, Ty translation, and then whatever you will obtain the final vertex you can use as the initial coordinates for the scaling, and whatever you will get output, that is the new coordinates after the scaling transformation, then you will use for the rotation purpose. Okay, so here the diagram is given already. It is a cuboid and different vertex are available here there with their coordinates. You can see A minus 10, 10, 10, B 20, 10, 10, C 20, 10, 30, D minus 10, 10, 30. Similarly, E, F, G, H. You can see in the diagram. Okay, so everything is available here, and then first you have to apply for the translation. So what is the translation matrix, or we can say that matrix formulation for the translation in case of the 3D? So we will use, first we will write the formula for the 3D matrix for translation. So x dash, y dash, z dash 1 equal to x, y, z 1 and followed by the translation matrix. Okay, so translation matrix we are already aware by the formula 100 tx 010 ty 001 tz 0001. So first you remember all the formulas which we will use either for the translation or for rotation or for scaling. Okay, so learn these formulas so that you can write those formulas in the form of the matrix frequently or either in the form of the equations. So as already mentioned in the problem, first we will apply the translation. Okay, we will write here x dash y dash z dash 1 and so on. Now put the value of tx, ty, tz. Okay, so here already we know about the values of tx 10, ty 10, tz minus 20. Okay, so here we will replace the value of tx, ty and tz, and then we will multiply these two 4 by 4 matrix, that is x, y, z1 by this translation matrix. Okay, and we will get x plus 10 comma y plus 10 z minus 20 and 1. Okay, so after multiplication of these two matrix we will write in this form. Okay, for our simplicity and for saving the time we will write in the form of x, y, z. These are the initial points. Okay, these are the initial points, or we can say the old points. So we can write in the form of x, y, z. Why are we writing here in the form of x, y, z? Because it is difficult to apply three transformation for each vertex. Okay, it is very time taking procedure. If we will apply all these transformation to each vertex, then the problem, the calculation may be complex and it will be very time taking. So it will be beneficial to write in the form of initial coordinates, that is x, y, z. Just I am multiplying these two matrix and writing in this form. Okay, now come to the next point, scaling. As mentioned in the problem, another transformation is scaling. So again we will write in the form of x double dash y double dash z double dash 1, and in place of here x, y, z1 we will choose the preceding result. Okay, the result of this matrix. So we will write in place of x, y, z1 the value of x dash y dash z1 this. Okay, so we can replace by this value x plus 10 y plus 10 z minus 21 preceding result followed by scaling. Okay, so first here we will write the formula for the 3D scaling, that is Sx 0 0 0 0 Sy 0 0 0 0 Sz 0 0 0 0 1. So first we will write the formula, and after that we will write in this form. Okay, so this is x dash y dash z dash 1 into scaling matrix. Okay, so in place of x dash y dash z dash 1 we will replace the preceding value. Okay, preceding value we already know that it was x plus 10 y plus 10 z minus 20 and 1. Okay, so we will replace the scaling factors here in the form of matrix, and again we will do calculation by multiplication of these two matrix. Okay, x plus 10 y plus 10 z minus 21 multiplied by this scaling matrix, and then again we will do the calculation here x dash y dash z double dash 1 is equal to 2x plus 20 2y plus 20 2z minus 40 and 1. So after multiplication of these two matrix we will get this. This is multiplication sign. Okay, so we will get this one, okay, after multiplication, and this is equivalent to the points after scaling, that is x double dash, y double dash, z double dash 1. Now come again. So the third transformation we want to apply as mentioned in the problem is rotation. Okay, rotation about plus x axis, that is rotation about x axis. So there are three matrix formulation if the rotation was given about the x axis or y axis or z axis. So we will choose the rotation about x axis because this is mentioned in the problem. Okay, so x again we will write x triple dash, y triple dash, z triple dash 1, and we will write here the preceding calculation obtained after scaling. So this was the matrix multiplication which we achieved after scaling transformation. Okay, then into followed by rotation matrix, and we will choose the formula rotation about x axis. Okay, so this is 1 0 0 0 0 cos theta sin theta 0 0 minus sin theta cos theta 0 0 0 0 1. So this is the matrix formulation for the 3D rotation about the x axis. Okay, about the x axis, and here this thing is multiplied by the preceding result. Okay, 2x plus 20, 2y plus 20, 2z minus 40, and 1. Again, the multiplication of 4 by 4 matrix to each other. Okay, so here x triple dash, y triple dash, z triple dash 1 is, will be equal to, again we will replace theta by 90 degree, okay, because it is already given in the problem theta is equal to 90 degree. So first we will put theta is equal to 90 degree, and after that we will find out the values of cos 90 and sin 90. Again we will change this matrix just after putting the values of the theta is equal to 90 degree. So here it will come 0, again cos 90 0, sin 90, here 1 and 0. Similarly in this case 0 minus 1, where 0 0 0 0 0 1. Okay, then we will multiply this whole matrix by this one. Okay, by this one, and we will get the generalized formula in the form of initial points x, y, z. Okay, so after multiplication with this matrix, we will get finally 2x plus 20, 2z minus 40, minus 2y minus 20, and 1. Okay, now we will compare x triple dash. Okay, so these are the point after three transformation. Okay, after translation and after scaling and then after rotation. Okay, and these are the initial points. It will depend on the initial points because we keep these points in the form of x, y, z. Okay, now whenever we will compare, then x triple dash, it will be equal to the 2x plus 20. Okay, this is the matrix. So we can write y triple dash is equal to 2z minus 40, z triple dash is equal to minus 2y minus 20. Okay, so first we will write in this form x triple dash is equal to 2x plus 20, y triple dash is equal to 2z minus 40, z triple dash is equal to minus 2y minus 20. And then we will write for vertex A. Okay, for vertex A, and whatever the initial points given in the diagram, in the diagram of the cuboid, then we will choose the values of x and y from there, and so that we can calculate easily the new points. Okay. So x triple dash equal to this, just we are comparing the two matrix, then we can write this value. So this is the generalized one. Okay. And whenever we will put the coordinates, that is for vertex A, we can check and we can calculate the value. Okay. So here we can also extend one more uh, column here for the coordinate system or for the vertex. Here we can write vertex A, B, C, D, E, F, G, H. Okay, and then can easily calculate values for vertex A. Okay, for vertex A, we will put the values as mentioned in the diagram. Okay, here A initial coordinates are for vertex A minus 10, 10, 10. Okay, so value of x is minus 10, value of y 10, value of z 10. Then we will put this value here. So we can calculate easily. Okay, so we will put the value of x here and then we can calculate here. So x is equal to minus 10 is provided, so it will come 0. Okay. Similarly, again we will go to to the diagram and then we can choose the initial value of uh, y and z and then we can calculate the final coordinates. Okay, so this is very easy and then you can insert in the table, so we will get these values like this. Okay, now it is very simple, otherwise you can do some sort of mistakes if you will apply all the three transformation for vertex A and then again do all type of calculation for vertex B, for vertex C, for vertex D. So it is very time taking and also you can do silly mistakes there and we will not get the proper output. So this one is the very simple method and in this way you can calculate soon, you can, and no chances of error here. Okay, so you have to follow, this is the shortcut method to calculate the coordinates, final coordinates. Okay, and the calculation here is not complex. Now we can see the case of arbitrary points. Here just I am telling you because maybe there sort of we can say confusion. Okay, so now again we are considering the case of the rotation about an arbitrary point. So we know that what is the arbitrary point and what is the origin. So just I am telling again, concentrating again, let us determine the transformation matrix for a counter clockwise rotation about point xc comma yc. So here xc and yc, these are the new points and we want to rotate our object about this point. Okay, about point xc yc, not about the origin, because we are already aware if we are going to rotate about the origin then it is the simple rotation, and whenever we want to rotate about the arbitrary points means we have to choose the new points. So xc yc, these are the new points, and then you can see how we are going to rotate the object about the arbitrary points. So there are few steps which we have to follow, and you can see that here we will apply three transformations. This is called the three transformations step. So what is the first? Translate the point xc comma yc to origin. Okay, whenever we are going to rotate any object about the arbitrary point, then first we will translate the point xc by c to the origin and then rotate about the origin. Okay, and third one, again translate the center of rotation back to xc comma yc. Okay, so these are the three transformations which we will apply if we want to rotate our object about the arbitrary points. Okay, so we have to follow these three steps. Now you can see in the next slide rotation about an arbitrary points. Just consider this diagram here. Okay, this is the origin. Okay, 0 0, and now we have xc comma yc here. Okay, above the origin, and now we want to rotate our object about this xc comma yc, not about the origin. Up till now we are rotating our object either in the 2D plane or 3D plane, but about the origin. Okay, and in case of the 2D, we are considering the case of rotation about the origin, but in case of the 3D, we can rotate our object about x-axis, about y-axis, about z-axis. But this thing is the new one. Suppose if we want to rotate our object about the arbitrary point, then what will happen? Now just we are considering xc comma yc. This is the arbitrary points. Okay. Now we want to rotate our object about this point, about xc by c. Okay. Just I am considering the case of the xy plane, 2D case. Okay. Now we have already told you to rotate the object about this point. First we will do the translation. So we will move xc by c here to origin. Okay, then these points become negative because we are going to downwards. So we will write, because we are moving downwards as compared to here, then we will replace the sign of this. Okay, if both are positive, then we will write tx is equal to minus xc and ty is equal to minus yc. So first we will apply translation, and after this step, now we can rotate the object about the origin. Okay, so we will calculate the rotation always about the origin. Okay, so whenever we are rotating our object about the arbitrary points, then first we will move towards origin. Okay, so what will happen in the first case, you can see. So this one is the first step. Okay, so we will do the translation. The translation which moves xc by c to the origin. Okay, so xc by c, this is the arbitrary points, and in the first transformation, it will move toward the origin, and we will get the translation transformation in this form. Okay, 1 0 minus xc 0 1 minus yc 0 0 1. We are already aware by the translation formula in 2D case, 1 0 tx 0 1 ty 0 0 1. Okay, because here we are moving xc by c towards the origin, so the sign of xc by c will reverse. Okay, so here in the first case we will change the sign of xc by c. Okay, and now we can write the first translation transformation in this form, 1 0 minus xc 0 1 minus yc 0 0 1. Okay, I hope it will be clear to you up to this point. Why we are doing this? Because we want to rotate our object about the arbitrary points. Okay, then first we will do in the first step, just we are changing the sign of tx and ty, and we will place xc by c. Okay, and after that we will rotate. Okay, after this we will rotate about the origin. Then we will use the formula cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. This was the matrix. Okay, whenever we want to rotate our object about the origin, then we will use this formula. Okay, and the third step, again we will do the translation in this form 1 0 0 0 1 0, and we will write the correct form. That is, again we are moving XC to its initial state. Okay, you have already seen in the diagram. So in the third case we are returning back. Okay, we are returning back from origin to the arbitrary points. So first we will do the translation, then rotation, then again translation, and in the third step we will write in the same way, that is 10 tx 01 ty 001, and here we will write the exact value xcyc, because we are moving from origin to again to the final state. Okay, so in this way we will multiply all three transformation, that is these are the initial point. Okay, xy1, these are the initial point, and then followed by P1 matrix, and then followed by R rotation, again followed by translation. So this is the translation, this is the rotation, and again translation. Okay, so we will do whenever we want to rotate the object about the arbitrary points. Now we can write T1 R T2 in this way, and here we will write, yes, what do you want to ask? Lalit Kumar,
Sir, nothing.
any question?
No, sir.
Okay, so XY1, T1, RT2. Okay, here we will write three matrix. This is the first one, value of T1 we will put here, and this is the first translation matrix 1 0 minus XC, 0 1 minus YC, 0 0 1. Okay, and then rotation matrix cos theta minus sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, and 1 0 XC, 0 1 YC, 0 0 1. So in this way we will calculate, okay, the value of complete T1 or T2. So we will multiply first these two matrix, and after that we will multiply this matrix by this one. Okay, so if the coordinates are available, that is arbitrary points are given, then we can replace the values of xc yc here, and then we can do the complete calculation. Okay, so just I am putting only the preceding matrix, this one. Okay, the values of T1, R, and then T2. Okay, so here we will put, here is no sign, just this is a cutting here. Okay, here this is no negative sign, cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, just I remove this sign here from here, and we will use the rotation equation. This is given. Okay, cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. So for the calculation we will write again here, and we will do the calculation, and we can multiply both three matrix. Okay, first this by this, and then the result we will get here this, and again you can multiply this. So this is overall transformation for a rotation by theta counterclockwise about the point XYZ. What is the XYZ? This is called the arbitrary points. Okay, so whenever we want to rotate our object about the new points, that new points is called the arbitrary points. And for rotating any object about the arbitrary points, we will do three transformation. First is called the translation, second rotation about the origin, third translation again. Okay, so in the first step, what we are doing, we are moving the arbitrary points toward the origin. So we are moving means we are translating. So we will use the translation matrix. Okay, but with opposite sign because we are going downwards. Okay, and then followed by rotation. So we will use the cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, and then followed by translation because we are moving back from origin to the original points. Okay, where it was initially. So again we will use the translation matrix formulation and then we can multiply easily, and whatever the result we will obtain, that is called the overall transformation. Okay, now again we will emphasize the different type of transformation techniques. So first is the, we are already aware in case of the 3D, again we will use the same transformation, that is the translation, rotation, scaling, reflection, shear. Okay, but mainly we will concentrate over the translation, rotation and scaling. So this is, we have already discussed regarding the 3D translation, rotation as well as the scaling. But again, if you have few confusion, then I want to clear again. Okay, so consider a point object O has to be moved from one position to another in a 3D plane. Now we are considering the 3D plane, and again we are considering the object O, and it can move from one position to another position. So this is called the translation transformation. Okay, either we are using in the 2D or 3D, but the translation means the movement of object from one position to another. Okay, so in this case, in case of the 3D, we will consider initial coordinates of the object as x old, y old, z old. Okay, in this case, we will use three x, y, z axis. Okay, then we can do the nomenclature like this: x old, y old, z old, or we can also use simply x, y, z. Okay, it is up to you. You can follow any nomenclature. You can either write x old, y old, z old, or simply x, y, 1. And for the new points, you can write x new, y new, or z new. But you can also use as the x dash, y dash, z dash. Okay, new coordinates of the object after translation. So after translation, you will get x new, y new, and again z new. Here again the printing mistake, typing mistake here. Okay, so new coordinates of the object after translation, it will come x new, y new, and z new. Okay, so it will come z new. Okay, so translation vector or shift vector, we can also called as shift vector or the translation vector. So this will be tx, ty, tz in case of the 3D. So just clear it. Given a translation vector tx, ty, tz, tx define the distance, x old coordinate has to be moved. Okay. Similarly, ty is the translation, that is y old coordinate has to be moved. Similarly, tz, z old coordinate has to be moved. So in this way, tx, ty, tz, these are called the translation or the movement. Okay, along x-axis, along y-axis, along z-axis. So you can choose any nomenclature here. Again, now we can see this is the 3D translation in computer graphics. Okay, so here these are the initial points O and O dash, these are the final point, x axis, y axis, z axis. Okay, so these are the initial point, x old, y old, z old. You can also use simply x, y, z. Okay, and you can also write here x dash, y dash, z dash as new. So you can either choose this nomenclature or x, y, z and x dash, y dash, z dash. Okay, it is up to you. You can use any nomenclature. Okay, so how we are going to move our object from O to O dash. Okay, so in this way we are going to move our object. So this is called the translation in 3D. Okay, now this translation is achieved by adding translation coordinates. In the preceding case, in case of the 2D, you have already calculated and used several equations for the translation. So what are those? X dash is equal to x plus dx, y dash is equal to y plus dy. Here it is new one, then z is equal to z dash is equal to z plus dz. So either you can write new or old or dash. Okay. So here x new, if you are following this, then x new is equal to x old plus dx, y new is equal to y old plus dy, z new is equal to z old plus dz. In this manner, in this fashion, you can calculate the new points for each vertex. Okay, in case of 3D also. So this is the matrix form. Now x new, y new, z new 1, and this will 100 tx, 010 ty, 001 tz, 0001, and here x old, y old, z old 1. Okay, so in this way you can indicate. Now there is a one formula, one problem. Given a 3D object with coordinate points A031, B332, C this, D this, apply the translation with distance 1. So here Tx is equal to 1, Ty is equal to 1, Tz is equal to 2. Okay, so Tx 1, Ty 1, Tz 2. So you know already the value of Tx, Ty, Tz. Now, so again we are choosing the same problem. Now it is already mentioned the initial coordinates of A vertex A, B, C, D. Okay, and translation vector here is Tx, Ty, Tz already given 1, 1, 2. Okay, Tx is equal to 1, Ty 1, and Tz is equal to 2. Already mentioned this. So how we will calculate the value of the new points for vertex A, B, C. Okay, after translation. So we are already aware by the formula. We can calculate x new is equal to x old plus dx, y new is equal to y old plus dy, z new is equal to z old dz. Okay, so in this way we can calculate all new values for vertex ABC. Okay, thus new coordinates for A is equal to 1, 4, 3. Okay, so for each node or each vertex, we can calculate the value of the new points. Okay, we are already aware by the equation x old plus dx, y old plus dy, z old plus dz. Okay, in this way we can calculate the new coordinates for A, B, C. So it is very easy. You can use calculate. So calculation for the vertex B. Okay, x new, y new, z new, and then apply the translation equation. Again, we will write x new is equal to x old plus dx, dy, dz in this way, and we can put this is the initial value already given 332, and we will write here 332, and we will put the value of dx, dy, dz. Okay, these are the very simple equation, and you can put the value of dx, and you can add simply. So we will get the final coordinates for B 4, 4, 4. Okay, similarly, you can calculate for the vertex 300, vertex C. Okay, again, you will use the same equations x old plus dx, y old. So, same in the similar way, you can calculate the new points or new coordinates for each vertex. So these are very easy to calculate. For coordinates D, similarly, you can calculate. Okay. And at the end, you can write thus new coordinates for the object A, B, C, D. Okay. So these are the new vertex after translation. So you can write in this way. Okay. So this is the final answer. Now another is the 3D rotation. Okay. How we are going to rotate our object in case of the 3D. Then I have already told you, in case of the 3D, we can rotate our object about x-axis, also about y-axis, or about z-axis. So here we will use the different metrics for each one. And initial coordinates of the object here is, we are again mentioning x old, y old, z old. Okay, rotation angle theta, and this is the angle of the object with the origin. So don't concentrate over this. Okay, initial angle of the object with respect to the origin, phi. Okay, but you will get the value of the rotation angle. How we are going to rotate our object about the origin, but the rotation angle will be provided to you. Value of theta will be given. Now, with the help of the equations or with the help of the matrix, we can calculate the new points, x new, y new, z new. Okay, so we will use the different equations. First, we will see that in the problem, the rotation is about x-axis or y-axis or z-axis, and accordingly we can choose the equation. Okay, so we are already aware there are three possible types of rotation: x-axis rotation, y-axis rotation, z-axis rotation. Okay, now we can see here this rotation is, if we are going to rotate our object about x-axis, then what will be the status of the equations? So x nu is equal to x old, okay, y nu is equal to y old cos theta, this is the multiplication sign, y old cos theta, z old sin theta, z nu is equal to y old sin theta plus z old cos theta. Okay, so in this way you can calculate easily the final values after the rotation about x-axis. Okay, you can calculate x new and x old. It will be equal. It will remain same. Okay, and y new you can calculate, z new you can calculate in this way. So this is again very easy, and this is the matrix form. X new, Y new, Z new 1, 1, 0, 0, 0, 0 cos theta sin theta 0, 0 minus sin theta cos theta 0, 0, 0, 0, 1, X old, Y old, Z old 1. Okay, so in this way you can use this matrix formulation for the rotation purpose about x-axis. Okay, so this is about x-axis. Just I am taking your attendance because only 1 or 2 minutes are left. Okay, so just you have to wait here. So that I can paste the same on my Word file. Okay, I am maintaining the record of the attendance. So this is the matrix form. Now you can already check and seen, and you have to remember these matrix. Okay, whether it is about x-axis or about y-axis or about z-axis. So again you can calculate for the y-axis. Okay, so I am just leaving your class here because after 2 minutes you can leave yourself. Okay, this time is 8:48. So for the y-axis, this rotation is achieved by using the following rotation equation. So again you can see we will use for the rotation if we are going to rotate our object about the y-axis. For the y-axis, we will consider the same equation you can see here, and in this case y will remain same. Okay, if we are going to rotate our object about the y axis, then we will see here y will remain same. Okay, about which we are going to rotate our object, then that axis coordinate will remain same. Okay, in the preceding case you can also check. In this case, whenever we are going to rotate our object about x-axis, then x-axis coordinates will remain unchanged. Okay, so this equation will not change, and we can calculate in this way the original points, that is the final points. Okay, and if we are going to rotate about y-axis, then you can see we are not changing the y values. Okay, so initial and final point will remain same in this case, and remaining will change. Okay, so in this way we will continue again the same lecture on the next time, and we will try to wind up them. Okay, thank you. Any question, please, you can ask. Any question you can ask, please. Any confusion till now? Any confusion? Hello.